Welcome to the Future Tech edition of the Finding Genius podcast. Forget frequently asked questions, forget common sense, common knowledge, or Googling for information. How about advice from a genius in their field instead? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond. They become very good at what they do, but only 0.1% are the geniuses of their profession. Richard has made it his life's mission to interview the geniuses of their fields in areas such as AI, 3D printing, quantum computing, blockchain and Bitcoin, and more. Don't miss out on amazing podcasts with geniuses. Review us on iTunes or wherever you listen, and go to futuretech.findinggeniuspodcast.com and subscribe today.
This is Richard Jacobs with the Future Tech and Finding Genius podcast series. I have a member of ESA, the European Space Agency. I've interviewed them a number of times. They always are very supportive in bringing guests to the podcast. So they brought me this time Arnaud Runge. He's an instrumentation engineer, life support and physics sciences. He works in various projects, but one big one is an umbrella called the Artist program. We're going to talk about some of the applications there. So, Arnaud, thank you for coming.
Thank you, Rich, for giving me the opportunity to present you what we do at ESA.
Yeah. Well, tell me about the Artist program. What are some interesting projects you're working on there that are recent?
So among the different programs that we are working for at ESA, there is Artist, which is an optional program for the member states of ESA, meaning that the different member states can decide whether or not they want to put money in that program. And I work on a program line that is called integrated applications, which is now called business space solutions. And the idea is to really promote the use of space for increasing the benefits of the daily life. So typically, how can we use all the things that space is producing? Should it be technologies, communications via satellites, positioning data, etc., to create new products and new services to either enhance existing services or to meet new needs from different user communities.
Yeah, what are some of the applicable technologies you've seen that you think will be able to be used by people on Earth?
Yeah, so typically the outcomes of the projects we are supporting via this program, they can be found in many areas of the daily life. They go from health, telemedicine, e-health, new technologies that are derived from things that we develop for our astronauts when they do exploration missions or when they go to International Space Station. But then we have many other topics like precision farming. So we help typically farmers to have a better utilization of the resources like water or the use of fertilizers to have less important footprint on the environment and make some economic savings as well. But we also work in domains like insurance, tourism, forest management, anything you want. As long as there is, let's say, an implication of a space element that creates, let's say, an added value for the users of this service. Due to my background, I work mostly in medical projects or aviation-related projects.
Sorry about the break there. Okay, yeah, we'll edit that out. So your focus mainly is medical products and aviation-type products. So what are a few of those that we can talk about?
So for the medical projects, we have a number of things. They are either originated by industry that comes to us and says, look, I have this concept of a new product or a new service for which space could play a role. And this is the case, for instance, for a project we had with a small company in the UK that is called Remote Diagnostic Technologies. And they came to us saying, we would like to develop a unit that is able to monitor a number of physiological parameters like heart rate or blood pressure or temperature and these kind of things. And we think that if we place this unit into aircraft, we could limit the number of unnecessary flight diversions that are due to medical reasons. So there are a number of these events that happen every year in the world of commercial aviation. And there are a number of them that are unnecessary. So people think that, for safety reasons, it's better to make the aircraft land and they want to take no risk. In a number of these cases, the flight diversion could have been avoided by just taking a medication or just like putting the victim at rest and just like continue the flight normally. So the idea was to have this aircraft equipped with a service, with a unit that can measure a number of parameters and communicate them to the ground, and also have like a direct link with a medical doctor on the ground to decide whether or not it makes sense to have the aircraft landing at a different place than the normal destination. And the interest is, of course, for the company is the image of the company, because you don't want to divert an aircraft if it's not necessary. But there are also cost implications, because if you land, then there are a number of fees to be paid by the airline. You have to compensate the passenger, etc., bring them to a new aircraft to bring them finally to their end of their journey. So that's how the adventure started in a way with this company. And since then, they worked further with us to really develop and mature the product that they initially proposed. And this has become so successful that Philips has noticed them, and they bought the company recently, like 2 years ago. So now we are still in contact with them to do a number of projects that are related to the upgrades of this unit. And what is very nice is that this unit is using positioning data. So they get data from our satellite to trace really the position of the units, and then the ambulance or the crew that is using the unit. But the unit also has a possibility to send the data over a satellite link, meaning that you are using...
A couple of quick questions here with it. How many incidents happen a year? How many medical incidents that cause diversions happen?
It depends on the company, it depends on the routes. I would have to find actually the exact figure.
Ballpark, are there like a few dozen, or are there hundreds? Is it
these are a few dozen, but basically, if you save one flight diversion, you're already, let's say, compensating the cost, the investment for procuring the device and all the associated costs, like the satellite transmission.
Yeah, I never thought about this, but on a typical flight, is there any ability for the flight crew to do anything medical? Or do they have to search around and ask someone if they're a doctor? And are they pretty helpless?
Well,
what can be done?
There is the typical question, like, is there a doctor on board? Which is probably not very comfortable for the passengers to hear, because then they suspect something is wrong. But typically, any cabin crew receives sort of first aid training, but they are visibly not experts. So what happens is that, for instance, when you have a cardiac issue, it can be just like fainting, but it could be also something more serious. And a cabin crew is not trained to answer this properly. So that's why you need to have some ground support.
Yeah, do they even have ground support? Do the airlines have one or more doctors on staff that could be instantly called and video chatted in? I mean, even that would help if they had something like that.
Yeah. Well, actually, I attended quite some time ago a conference on the very long haul flights and the need that you have telemedicine on board and these kind of things. Well, some of the people claim that you have like telemedicine because the pilots from the cockpit, you can use VHF and make a call. This is true, but actually when you are over the ocean, over the Atlantic, well, sometimes the VHF is not the best solutions because the waves are not propagating very well. So you have a poor connection. So satellite is the way to bridge the aircraft to the ground. But anyway, this example was just the starting point of a collaboration that further matured. And more recently, we have used these technologies with air ambulance services. They use helicopters around the area of London in the UK. And typically, for them, it was really a great improvement on the way they work. For instance, during the trial of the project that we had, they supported more than 50 cases during which they used the technology to get the physiological data of the patient and bring it already via a connecting link to the hospital so that the hospital could get prepared to the arrival of the patient. And just recently, they used it for a tragic accident where a 7-year-old child was stabbed in the heart, and the medical team did an emergency open chest surgery, and they used the technology that we support to develop. And they sent the data to the receiving hospital, and so far the child was doing very well. So that's just one of the several cases where it has been used and made a tremendous positive impact on the patient care. So for us, that's obviously a very nice achievement.
Yeah, no, that's good. Yeah, you're right. I mean, there's not much going on apparently on board flights, so it needs to happen. So what other
Yeah.
what other medical products have you worked on that are going to have an impact?
So, so the one I just mentioned is one of the most successful one in terms of, let's say, technological maturity, technological readiness, but also on in terms of commercial results. Because as I mentioned, the company has been bought by Philips recently, and they have sold a lot of units to different countries, to different kind of users. But we also worked on some other projects like a laboratory that is able to make some biological measurements, especially in the context of epidemics. So the laboratory is managed by a Belgium research center, and that is located near Brussels. And they just got certified, let's say, as a tool by the European Commission to react to major crises in the field of, let's say, biology and biological threats. And you might have heard about the Ebola crisis that has been striking a few years ago in Africa, in particular in Guinea. And this was at the time we were running the project. So we used this opportunity to really fully validate the lab and the technologies we were working on in this context. And typically, the lab was deployed in one of the places where Ebola was striking. So what is remarkable about this is that the lab is able to connect via satellite and to reach out experts that are in a way required to deal with Ebola. And as you know, Ebola is a very fast evolving disease, and you needed to have access, I wouldn't say in real time, but let's say very rapidly to different kind of specialties. So for instance, specialties in immunology, in hematology, and in pediatrics where kids are involved. And so the fact that this lab has this SATCOM capabilities was enabling the specialists to talk with the experts that were deployed on the ground to adapt really the treatment for the different patients that were met. This was also very instrumental as well to manage all the stocks of consumables, as well as for the teams that were deployed to have, like, let's say, frequent contact with their families. So it was really boosting their, let's say, their willingness to work and complete their mission in a very effective way. So it was very good for their morale.
Well, what are some of the things that happen when there's an outbreak of disease that, cause issues? What are some of the inefficiencies?
So what happens is that, of course, when these outbreaks, they happen, they are not always taking place in cities. That was the case in Africa, for instance. And there are villages that are not able to be connected via the normal phone networks. 3G, 4G, doesn't work. And in some cases as well, if you rely on, let's say, conventional communication lines, which are terrestrial networks or phone networks, when there is really a major crisis that can be caused by natural causes as well, you cannot use these systems. So satellite is really making the difference, because you cannot basically break the satellite link, and it allows you to transmit a number of data and connect with other people in a very fast and reliable way. And you can also send quite a huge amount of data. So in the case of Ebola, for instance, there were a number of samples that were analyzed, and all the data was sent to Europe for being checked by experts, so that they could see, like, if they would be at the place and provide their feedback in a very fast manner. And we could see, although of course it was not a comparison, but with other labs that were not enhanced with space technologies, we could see the difference in terms of effectiveness of the answer that was brought to the populations. So with this lab that was SATCOM equipped in a way, the area has been completely cleared of Ebola, while the others, they were a bit struggling with it. So again, that's a good proof that space can really make a great difference in the way services are being developed and provided to populations.
Do you know what the coronavirus outbreak, if this technology is going to be used or is being used?
So the technology, in a way, is agnostic of the virus or let's say the biological threat, because what we will do, the people in the lab, they will just like take some samples. They will inactivate the viruses or the bacteria. So in a way, they will make it harmless, but still they will be able to detect them and analyze them and make sure that we can bring the best possible answer. So it's completely agnostic of the kind of infection that is found on the place, which make it a very versatile tool and can be reused in different kind of places with different kind of pathologies. So typically you could have this tool used for yellow fever or for SRAS or any kind of things like this.
Okay. You mentioned medical technologies and then another area, aviation. Having better medical care on board for flights obviously brings the two together. Are there any aviation-specific ones that you want to talk about?
I mentioned this too because actually my background is twofold. So on the one hand, I have a master degree in medical engineering, which is like the initial step I took at ESA, working as a medical engineer there. But I also qualified as a commercial pilot, and I have quite some flight experience. And I also give this expertise to ESA for more aviation-related projects. So there we are having a number of initiatives that we support to improve the performances of airlines or improve the effectiveness in the way airports are operated, for instance. To give you an example about airlines, and we are working with a company that is based in the UK and works on data analytics to make sure that the aircraft will have, a better way to manage the health of the engines of the aircraft. Nowadays, an engine is a huge cost, a huge part of the cost for an aircraft, and you want to make the best use out of it, and you want to avoid, in particular, unpredicted maintenance schemes. This happens, for instance, if you have to fly around a volcano, or you have heard about the terrible fires that are taking place in Australia. So, of course, if you fly in the vicinity of these events, the air that will go into the engines will probably damage some of the internal parts of the jet engines, which means that the companies have to take the aircraft on the ground, carry more inspections, or maybe replace some parts in an earlier way than it was supposed to be. And the idea is that using satellite data, Earth observation data, combined with a number of models, atmospheric models, the idea is to make sure that we can adapt the route of the aircraft to minimize the impact of the environment on the engine health. At the same time, we can do the opposite. We can really amend the route of the aircraft to make sure that we'll use less fuel and avoid areas, for instance, where there are ice crystals in the air. And these ice crystals, they also have an impact on the health of the engine, but they come also with a penalty cost for the aircraft. Because when an aircraft is flying into ice crystals, they have to burn, let's say, more fuel to de-ice the engine. And this more fuel is a cost for the company, but this has a negative impact on the environment. So by choosing more carefully routes, by analyzing a number of data that are taken by satellites, we can improve the economical effectiveness of the company, and we can improve the footprint on the environment from the aircraft operator. Everybody's
why are ice crystals such a big deal? And what happens if you have to fly a route wherein ice crystals could form, or is there a technology that would stop them from forming? Let's talk a little bit more in depth about that.
Yeah, so these ice crystals, they will be ingested into the aircraft, and they will melt, and they can damage some critical parts in the turbo engines because they will create, for instance, temperature differences. And the idea is that the engines, they are like very nice pieces of technology, but they are also very fragile. So what we want to avoid is that these engines, they go to more frequent inspections because of the potential risk that are triggered by these ice crystals and the modifications they could imply to the engine material structure. So this is a well-known issue to pilots, And whenever possible, they try to avoid these ice crystals because they really can damage the engine blades of the aircraft.
Well, how do you avoid them? I mean, if you're up at certain altitudes, I would think they just exist. The relative humidity of the air you're flying through. I mean, what are some measures they could do to prevent them?
So that's where modeling and satellite observation data can enter into the game, because there are conditions where these ice crystals can form, and there are positions where we are more likely to, an altitude where we are more likely to find them. So typically, by feeding the model with the data and the observation from satellites plus running the model, we'll be able to kind of predict where they are and adapt the routes to avoid these locations. So in some cases, one might say, okay, you take a longer route, but if you take this longer route, but in the end the cost, the fuel penalty cost is less, you will still gain and you will preserve your engines. So it's really kind of a predictive tool to choose the best routing that you can have to avoid these ice crystals areas based really on observation data from satellites.
Are there any programs right now that can optimize a jet's fuel use? You know, maybe have it speed up in certain parts or slow down, or go to higher or lower altitudes, or take different paths? And I don't know what factors would tell it to go one way or another, but are there programs like that? Or is it just cruise control the whole way?
The thing is, the routes, so they are really computed based on all the data that are acquired during the flights, because the aircraft nowadays, they are full of sensors. So the idea is that each flight is analyzed on the ground by specialists for the major airlines. And they compute all the data, they check the fuel consumption, and they have a kind of, let's say, map of anything that can increase or decrease the fuel consumption for a flight. So for instance, over 1 year, they will measure all the flights from a point A to a point B, and they will check each time based on the different altitudes or let's say, route that is taken, if there is a fuel consumption increase or decrease. And based on that, they will build statistics to automatically adapt the routing and hopefully go for, let's say, faster flights with a lower cost of the fuel. And space can help as well here, because with the data that we provide with the observation satellites, we can feed this data into the models and help the specialists on the ground to understand what is best for the routing of the aircraft. We have actually currently a project which is run by a Dutch company, and the idea is that they will propose a 4-dimension model, so a 3D model plus an evolution across time of the atmosphere. Less for large airlines, but rather for general aviation pilots and business jet operators, because these stakeholders, they have not such a big weather support office to help them preparing the flights. So the idea is that in real time, these pilots, they can be connected via satellite communication systems and receive an update of the weather while they are flying. So with this idea of, again, improving the performances of the aircraft, so maybe going to higher or lower altitude and have a more favorable wind, so therefore consume less fuel, but also at the same time, they will maybe have a safer flight, because not all aircraft are able to cross bad weather, which can have like turbulence or icing conditions that are associated to the clouds in which they fly. So this is another kind of service that Earth observation data and SATCOM can bring to aviation stakeholders, is to help them to better prepare and execute their flights.
Well, very good. Arnaud, what's the best way for people that are interested to see these projects and more? Where can they go to find out what's coming and what's in use?
So we have a website which is business.esa.int, In there, you will find the list by category, by topic of all the projects we have been supporting. So I mentioned different topics, of course, health and aviation, but as I said before, we have plenty of topics. And they will find there a description of the mechanisms that we have in place to support new projects, new services for the benefits of everybody. And they will, by going to this website, so they will get an overview of what we can do. And if they decide to apply, they can get from ESA some financial support, but also some expertise, technical or more business oriented, to make sure that their project will become a success.
Well, that's great, Arnaud. Thank you for coming on the podcast. I appreciate it.
My pleasure.
You've been listening to the Future Tech edition of the Finding Genius podcast. This podcast is information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed. Review us on iTunes or wherever you listen, and subscribe today by going to futuretech.findinggeniuspodcast.com.